Hello, I'm Thomas, the pilot, flying the Airbus A340 300 and the Boeing 737-800 NZX. And tonight's flight, we're gonna be flying from Zurich International Airport back to Zurich International Airport. We're gonna be flying a flight level 250, 25,000 feet, with Mach 0. Maybe 86 or 0.82, and right now I'm in the cockpit for the aircraft engine starts and pre-takeoff preparation. So maybe we're gonna make a engine start demonstration while I'm going to be explaining you some of the aircraft systems and engine systems. So here is the cockpit of the Airbus A340 300 313X, as they call it, or 311. Here we have the outside view. You can see the engines here and the thrust reversers, so like in this aircraft. It's very nice simulation, has a lot of high detail. So I was telling you I'm gonna be flying this aircraft and I'm gonna be explaining some of the systems. Now we're gonna proceed in the engine start sequence. So here is the cockpit. This is the side stick I used to fly it, which is a Logitech 3D Extreme. This is the thrust levers. Here is the pitch up of the horizontal stabilizer elevator, and this is the pitch down. Fly-by-wire order, because this is fly-by-wire aircraft. This is the left turn, and this is the right turn by turning the ailerons and the spoilers in its wing in respective bank roll order, left or right, as I'll show you right now. And this is pitch up and pitch down of the elevator in the horizontal stabilizer section of the aircraft. And you can see these limits here in the primary flight display as I move the side stick up and down. This cross shows the G actually limit and the bank angle limit that we're gonna have in flight, and the pitch up and pitch down limit. So this aircraft is limited to like 67 degrees in bank roll order in the left or the right, and 30 degrees up and 15 degrees down. So with 33 degrees bank roll, there is no need also for making corrections in the trim, because there is an auto trim system which is managed by the flight management computers here, based on the weight and balance of the aircraft, the fuel and many factors like the airspeed. I'm gonna be explaining later about this thing. So now we're gonna make an engine start. Maybe I'm gonna show you here. Here we have the primary flight display. You can see when I move the thrust levers all the way forward, all the engines. You can see the manual takeoff go around is on. And you can see here in the engines the TOGA message, which is 93.9%. You can see the engine thrust increase. Here is the N1 is the low speed rotor front fan section of the engines, which is 93.6%. The exhaust gas temperature, the N2, which is the high speed compressor and high speed rotor of the engine section, which is 98.5%. The fuel flow is 13,980 pounds per hour per engine. And we have fuel on board 70,300 liters, which is 30% of the total fuel. Here we have additional engine data. So we can see like the oil quantity, the fuel used per engine per hour, the PSI, which is the pressure in square inches, the temperature, the vibration in the N1 section, and the vibration in the N2 section, and this is the intake temperature, if I remember well. And so we have other factors like the gross weight center of gravity, the next page, zero fuel weight. Here we have I think we have like 390,000 pounds right now. Minus the fuel, it should be 320, 73,000, 72, yeah, 390 minus 70, which is 320 extra human pounds. The block fuel 71,000. Let's say this is 72,000. Here we have the takeoff weight 389,600, yeah, 390,000 pounds, which is our takeoff weight, and zero fuel weight center of gravity, 28.6%. So I'm gonna be showing you now an engine start. So we need some additional systems to start the engines. We need the APU, which is the auxiliary power unit, which is used mostly for the starting the aircraft engines in the ground, and provides bleed air and electricity and hydraulic power when we have no engine electric or hydraulic power or external connected systems to supply the aircraft. So I'm gonna show you an engine start and a very quick flight. So this must be ready for the APU right now, if I'm not mistaken. Here we have it. Here is the bleed air from its engine into the bleed system of the aircraft, which uses this bleed air to pressurize the cabin, to pressurize the hydraulic pump units, accumulators, and to also provide the air conditioning and some other functions maybe. And here we have from its engine the pressurized air in PS with pound square inch pressure, which is 50 psi from its engine and 182 degrees Celsius. And we have the valves here, which are open from the intermediate pressure section, not the high pressure. Yeah, both in the high pressure section. They're both of them open. So I'm gonna turn the engines off. Show you some. Now you can see there is no pressurized air from the engines, and the engine power is going down. So here we have the electrical. As you can see, we lost the generator power here in the electric, the alternate current. SSL transformer, which is used to feed the batteries and the systems that use direct current through the transformer rectifier units. Now we have in the APU generator alternate current contactor is feeding the alternate current essential TR system. So we have electric power from the alternate electric power from the APU to feed the batteries here. And also we have from the essential transformer rectifier, yeah. We have some static inverter. We need direct current to be converted to alternate current. Here you can see the electrical panel overhead. Over here, here is the bleed air I was telling you. You can see the switches. Here is the fuel section. I'm gonna show you later if we have time. and we're gonna just start. Here's the jump seat. We have another view over here. So maybe if I magnify this a little bit, you're gonna see how the systems work. So here we have it. Electric direct current. So if I disconnect the batteries, we have direct current from the APU. But if I disconnect the APU, I connect back the batteries. You see there is no electricity right now. We have no APU power electric, only direct current from the batteries, which is shows us some fault displays over here in the upper ECAM display. Electric DC bus 1 and 2 volt, electric alternate current bus 1 and 2 volt, and the engines are off right now. You can see some screens are went off because there is no alternate current right now. So if I connect back this little switch over here, you can see the APU contactor. The APU is running right now. You can see the blue over here in the switches. APU master and start, which is available. So I'm gonna press it back, and here we are. We have electrical back, alternate current electrical, and here is the pressurization I was telling you. The bleed air, actually, from the engines. We have engines off right now, so I'm gonna use the APU bleed. Now we have bleed air from the APU, which we can use to start the engines. So I'm gonna turn this in this position to start the left section engines first. So we're gonna use the bleed air this way before the engine started. Here we have the electrical generators. It's in default position, so we actually have no electrics. It's off if I press this button. So if I press it back, it's on, but there is no electrical. And this is the same for this side engine. So I press it off, it's going off. Press it back on, it's going on. So here is the fuel panel, which is the fuel pumps. I'm gonna show you later, and the hydraulics. I'm gonna be showing you later this system. So we go back in the engine start. I'm gonna use this switch over here. The engine mode selector, as they call it. I'm gonna move this in the ignition start, which closes the packs. I can close them also manually if I want. We should close the packs in the off position for starting the engines. So I'm gonna move you can see this lever here, which is the engine 1 lever. I kick it in, and you can see there is something going on now because the engine started and the FADECs are initiated the engine start sequence in the engine number 1. And I can do that for both engine number 1 and engine number 2 if I want. We'll have the additional engine data. You can see. I'm gonna use the other side. You can see the engine here is starting. Here is start moving already. So I'm gonna move and this switch which initiates the FADEC, the low and the high pressure valves of the fuel, and the engine started. The engine starter compressor, which admits air from the air pressure section of the APU to compress the air starter. And here we have it. The engines start. We're in a good position right now. So I'm gonna turn these switches here on the other side to initiate. I can use it in the open or the auto position, so I'm gonna start engine number 3. You can see the low speed rotor turbofan engine stage would start moving. I don't know if I can show you from here, maybe. Yeah, here we have it. Start the engine. From the other side also. So there is only one engine left, engine number 4, which is 4-engine aircraft. On 5, 1, 6. You can see when the N2 is gonna reach about 20%. I think the low pressure valve of the fuel opens and admits fuel to the engine very rapidly. Here you see it. This is what happens in its engine. And the FADEX, which is the full authority digital engine control computers, control the engine start sequence and many other factors like the thrust lever position. When I move the thrust levers here, it's controlled by the FADEX, which then manages the fuel flow and the N1 and N2 rotation speed of the fan stages, the fuel flow and the exhaust gas temperature, that everything is within parameters for a normal flight. The vibration, the PSI, the oil quantity, many other factors. And it feeds this data into the ECAM and the flight management and guidance computer and the flight control unit over here, which uses for the auto thrust. When I turn the auto thrust button here, you can see we have it on, the auto thrust system, which commands the engines to take off, go around right now. Now it's in the idle, thrust idle, as you can see, because I hold the thrust levers in the idle. So if I'm gonna come back to this section, I'm gonna use the packs. We can use them in the off for takeoff. Use this in the other side. Here in the auto position. Everything else is managed correctly. So I'm gonna start configuring the aircraft for takeoff. So I'm gonna set up a quick. We have set up the zero fuel weight center of gravity and block fuel, which is in the fuel tanks. I can show you here fuel tanks. Guess how much fuel there is in each tank. It's wing tank, inner tank, outer tank, center tank, and trim tank into the horizontal stabilizer section, the tail section. The fuel used per engine and the fuel flow, which is on over here. So here we have I'm gonna initialize the flight plan very quickly. From Lszh to Lszh, from 0 to 0. Align the RS. Our flight altitude. Our flight number is not necessary, so I'm gonna escape that. And here we have flight plan thing from before, maybe? No. So I'm gonna use departure from runway 14, which we are seated right now. Use a standard instrument departure, Zuid to Alpha, enable cruise altitude, and then arrival into this same airport, which is gonna be LS14 Transnegria, Transamerica with a star Negria. So Negria 1 Alpha. So we clear the discontinuity. So here we have the flight plan created, which looks like the Boeing's flight plan I use some other times. So I'm gonna add some maybe airports and increase the range here, so you can see a little bit more stuff in the navigation display, which shows our flight plan, which is our horizontal and vertical guidance flight plan. Our heading right now, which should be aligned with the runway heading. If I turn the localizer, maybe the ILS, I'm having the ILS inertial instrument landing system frequency set here from the flight management computer. Sets over here in the radio management panel automatically the frequency for this runway, which is a radio kind of approach for horizontal and vertical guidance. You can see we are perfectly aligned. We have the magenta here, which shows our NR India Kilo Lima 108.30, which is the radio frequency. So I'm gonna set the flight altitude now. I'm gonna move this in the big units, the thousands. Maybe if I can, yeah, you can, why not? All the way to 25,300, and our heading is gonna be Manads, or I can use yeah, I'm gonna use the runway heading and a little bit more airspeed. This is a flight control unit, the FCU flight control unit of the autopilot and the autothrust. It has two autopilots. This is the airspeed that I'm using now to do 250 knots. Gonna use, which is more our V1 and V2. And this heading should be Manads actually. I don't know why it doesn't. Here we have it. Yeah, that is correct. Here we have the flight mode annunciator in the primary flight display. This is primary flight display. The airspeed tape, 250 knots selected airspeed to 85,300 feet selected altitude. You can see the horizontal situation indicator, which shows our vertical and horizontal guidance of the aircraft, our bang angles, our pitch, and many other things, which is used here from the side stick, from the thrust levers, the flight management computers, and the autopilot settings. I'm gonna show you how to fly. This is our barometric altitude above sea level, which is 1,480 feet. We're gonna have a radio rider altitude. Here is -1 right now. So I hope we're gonna have this here. I'm gonna set only the flaps for takeoff. The flaps increase the lift of the wing by increasing the wing surface to produce more lift when the aircraft fly. So here we have it. I'm gonna retract the spoilers and So we have it here in the performance. I'm gonna use flaps 2 and pitch trim 20 up. The pitch trim is the horizontal stabilizer trim here over here is moving the tail section of the aircraft. Over here the tail of the aircraft up and down, the whole tail, to balance the aircraft in flight. So we can do also this like that, but do only the elevator section of the whole horizontal stabilizer. So I'm gonna use pitch trim 2 up here. It's a move like that. So you can see the flight controls. Here we have it, and we're ready for takeoff. You can see the print computers, the sex computers. When I move left and right, the side stick, you can see the input here, the ailerons and the spoilers, and the pitch up and down over here, and the rudder. The rudder is here in the rudder pedals. So here we have it, we're ready for takeoff. So I'm gonna advance the thrust levers all the way up to the takeoff go around. Disconnect the parking brake. Try to align a little bit. Now we have 28 minutes for this flight, so we have to be very fast, because this video ends in 28 minutes. So here we have our V1, it's almost close here. We rotate, V2. I retract the landing gear. And we have a climb bar now. You can see in the flight mode annunciator we have the modes, the flight mode. We're perfectly aligned with the ILS. I'm gonna keep climbing actually. Now we have a managed heading, which shows the actual flight plan we're gonna follow. So I'm gonna retract some flaps now to have more airspeed margin over here. You can see our airspeed right now is 190 knots. Our radio altitude is 1,700 feet above the ground level. 1,900 feet above the ground level, 2,000 feet above the ground level, while our sea level altitude is 4,000 feet above the sea right now. We are much higher above the sea than we are above the ground, as you can see here, the terrain. So here we have it for the takeoff section of this flight. You can see the Airbus A340 300 aircraft. It's a very beautiful aircraft. So I'm going back into the takeoff section here. Navigation display. We have to move the thrust levers a little bit down to the glide deaden here. And we have to decrease our rate of climb because we have some marking of the maximum angle of attack airspeed, which is gonna stall the aircraft. We don't stop climbing with so much high rate of climb. You can see now I'm using the climb thrust. So we have 25 more minutes for this flight before this video ends. Like not a record. In one video more than that. Let's now move the side stick. It moves the aircraft. With the flight control. So I'm gonna show you some views here. Some nice views, maybe. Some of the engine views here I'm gonna show you. the other side ends. It's also nice. You can see how this aircraft has 4 engines, very powerful aircraft. So I'm gonna try to climb faster now. So maybe not use the managed speed. I'm gonna use my own airspeed. I'm gonna increase the airspeed a little bit to a safe glide speed of 25 knots over here through the FCU, which makes the airspeed selected right now, not managed. So it's gonna to increase the commanded thrust a little bit. It's 88.9%, so it's fixed thrust mode, which manages the airspeed of the aircraft by the rate of glide or descent. It keeps the thrust stable, and so maybe we have to use the takeoff go around again thrust, or the MCT, to give us a little bit more thrust or airspeed, and then back use the glide then again. So here we have another 3 minutes for this flight. I'm gonna use the takeoff go around thrust for this, because I need a little bit more of the MCT, maximum continuous thrust. Gives me 90.6, 90.7, a little bit better. I'm gonna have a little bit more thrust, maybe takeoff go around. I can use it for 10 minutes in this aircraft. I'm gonna have a lot of thrust for the climb. We have another 22 minutes for this flight. So maybe fly track the flap, but I'm not sure. This is gonna help a little bit. It's gonna decrease the drag of the aircraft. A little bit more airspeed. You can see the stall margin over here. Just pay attention not to reach the stall margin, because it's gonna to initiate the alpha protection system of the aircraft. It's gonna lock the takeoff go around speed and limit the pitch up order from the side stick through the fly-by-wire system of the aircraft. And this is commanded by the flight management computer, if I remember quite well, the Alpha Prot system. So yeah, we have a little bit more airspeed now, 200 knots, a little bit better climb of rate, 2,500 feet per minute. So we're gonna be in 4 minutes our maximum altitude, and then we're gonna have 15-16 minutes to go back into the airport for landing. So I'm gonna try to climb faster, maybe in a couple of minutes. 3,600 feet per minute. Yeah, we are at 19,000 feet almost. Yeah, 19,000 feet. 200 knots. We're quite safe right now for our airspeed. We have our waypoint here, which we got 20,000 feet. We crossed 20,000 feet right now. Keep climbing. Maybe we're gonna have some chemtrails in a while, like in a couple of minutes. 21,000, yeah, maybe faster. We need 19 more minutes for this flight, so maybe we're gonna start turning back into the airport and then show you the chemtrails to save some time on the turn. I think we're gonna have chemtrails in a while. Yeah, we have it. Here they are. Here we have the chemtrails. We're quite high now, so the air is cold enough to create this phenomenon. Chemtrails. You can see we're very close to the stall speed, and we also reach our maximum high altitude for this flight. So we're in good position. We almost got into the stall protection stage. So I'm gonna decrease this to the MCT now. And turn the aircraft into the airport. We are at 25,000 feet, we're gonna hold level maybe later. I'm holding level 25,000 feet with Mach 0.4780553. We're going very fast right now. Actually, we're accelerating very fast, 240 knots. So turn back into the airport position for this flight. You can see the chemtrails being created. But this huge aircraft is almost 200 tons right now. 390,000 pounds. So I'm gonna see some more of the inside now. You can see here this section returning a little bit more climb. So we have 16 minutes to go into the airport. So I'm gonna use maybe the direct to the airport, but I'm not sure. I'm gonna try first to turn into the airport direction and then trying to level off as I was saying. So we're gonna decrease the thrust a little bit to the glide. We have an overspeed right now, but there's no problem with that. You can see the auto trim here. So I'm gonna move this back again. We pass through the overspeed. Well, we can see the chemtrails here. You can see how stable this aircraft is because of the flight controls of the fly-by-wire system, which streams automatically the aircraft based on the center of gravity and the acceleration and airspeed. So I'm gonna show you maybe a little bit more inside how we can turn now back to the airport. I'm gonna use the direct 2. We're gonna be flying direct to the final waypoint, the final fix for this flight, which is actually 41.2 nautical miles, 41 nautical miles away from us. So maybe we have to start descending a while. Maybe like a couple of minutes. We have 13 minutes, yeah. We have to start descending. So I'm gonna roll this down to the 7,000, which is gonna take us down to the airport very rapidly. Gonna start descending very rapidly with high speed command right now. I'm gonna keep decreasing this. 7,000 feet. We have 13 minutes to go to the landing, so we have to be very fast for this. I lost a lot of time up there, so the entrance of the aircraft. So we are 22,000, yeah. I'm gonna use the climb again. You can see the auto trimming the aircraft down a little bit, I think. Yeah. We have a little bit more airspeed, I know. It's because of this. Oh, I need to do that, yeah. Forgot it. Select the altitude. So this is gonna change the flight level command by the FCU. So make this shorter a little bit. We have another 11 minutes to go, so I'm gonna need a little bit more speed, I believe. For this descent into the airport. We're descending right now. I have to activate the approach phase. You can see some stars in here. I'm descending quite rapidly, and we have 10 minutes to go. We have to land very fast, actually. So I'm gonna make a fighter jet, I believe, again. Kind of landing. Maybe use a little bit more airspeed. It's not bad. I'm gonna get there faster. Again, maybe a little bit lower. You can see the airport here in a while. We have exactly 10 minutes to go. We are 12,000 feet. I'm gonna use the localizer in a while. So we are 17 nautical miles away from the spot that we have to be. The airport must be around here. The runways. 10,000 feet. Can we get faster now? We're 14 nautical miles away, so we have to slow down. 9 more minutes to go. Nautical miles to go. Here we have the runways. Here is the airplane. So we're gonna overfly that. So I need to go a little bit faster. We have 5, we have 8 minutes to go. See, oh, we are in a good position right now for landing into this runway. Yeah, I can see the runway lights here. I'm gonna use this one, the 1-4. I'm gonna descend a little bit more further, make a nice turn and land this aircraft smoothly. So we have 7 more minutes to go. To be more fast. We overshoot the runway. We're going down for the fix, which is 3.6 nautical miles away, and then 3.6 nautical miles back. So I'm gonna descend a little bit more. Here is the river I use for spotting the runways always. So I'm gonna start, maybe we have the lock arm, the localizer arm, the Lszh arm. So maybe I'm gonna use the speed brake through the landing gear. Slow down a little bit. You can see what happens here. Have the landing gear coming down. So we're gonna turn this aircraft now into the runway. I'm gonna use a little bit more thrust and some flaps. We're gonna use MCD thrust. We need this for this turn. And then use full flaps just to land. We're at 2,500 feet, so we're gonna descend a little bit more and move all the way into the runway heading. So we have another 4 minutes to go. I can use a little bit more thrust. Now we have to align only with the runway. You can see I'm holding a good thrust right now. I'm holding manual thrust. configure the thrust manually right now, moving thrust levers and manual side stick inputs. So maybe we descend a little bit further. We can have the flight director here. We have descend a little bit more for this approach to follow the glide slope here and the Lszh localizer. So we have 3 more minutes. Here's the localizer. We have to go a little bit more to the left and a little bit. We are right now in the proper position in the altitude. So I'm gonna hold level and make a little bit to the left. Some corrections. Now we are aligned. We have 2 more minutes to go. So here we are. Two more minutes exactly. I'm going to decrease the thrust right now, descend a little bit. You can see the position that we are right now, 500 feet. $35, and here we are. Parking brake and reverse engine. Thrust reversers. Here we are, perfectly safely land. You can see there is no damage in the landing gear. We have only the reverse thrust here. Both the landing gear I'm closing the reverse thrust right now. You can see the landing gear here, the tires, and the nose wheel is perfectly safe. There is no damage over there in the tires, no blown tires. So I'm gonna be showing you here. Here is the reverse thrust. I'm going to close it here by the. So we're perfectly safely landed. So that was Thomas, the pilot, flying the Airbus A340-300 in this flight. I'm also flying the Boeing 737-800. Thank you for joining me in this flight. I did some explanation of the Airbus A340 aircraft system. We did an engine start sequence and then a flight with takeoff, cruise, takeoff, climb, cruise, descent and approach, and then landing manually. Everything was manual. So I'm gonna be seeing you in the. We have a little bit more time. I don't know. See you in the next flight. I'm gonna be seeing you here.